today a little more on atomic anatomy and finding those parts. So just a little review of some things you'll definitely still need to know. But to find the number of protons, it's going to be your atomic number, that top number on your periodic table. Number of neutrons is still going to be mass number minus atomic number, or again, that's the same as the number of those protons. And then to find electrons, if it is an atom, not an ion, and that'll be a change today. Some things may have a charge, but if it doesn't have a charge, these things are going to be equal. So that's stuff for review. This stuff a little new, not going to change a whole lot about what we do, but a few little tweaks. Isotopes. Every atom is an isotope, and all an isotope is, it's atom of the same element with a different number of neutrons. And then this is why that average atomic mass is a decimal. It's 1 because we have these atoms with different masses, and some occur more naturally than others, so there's a different percentage, and that's where we get that number from. Isotope notation, a couple ways you're going to see pretty much everything written, because it matters that we have a mass number. So one thing is just hyphen notation. You'll see as the element name with the mass number afterwards, and sometimes if I'm lazy or whoever created a worksheet is lazy, you might see something like C12, where they just give you the symbol and the mass number. The other one, nuclear notation, is awesome because it gives you everything you need to know. You don't even need to look at a periodic table. And that notation, AZX, is what you see it as, where A is the mass number, Z is the atomic number, so now I have mass number and I have number of protons. Instant subtraction, I can get number of neutrons if you just subtract those two. Where, over here, I don't know what the atomic number is, so I have to look at the periodic table. Not here, that's awfully nice. And X is just your element symbol. So example here, same element, carbon-12, or same isotope, sorry, carbon-12, mass number up top, atomic number is 6, so instantly you know how many neutrons. It'll save you a little time. Nice to have that way. Some examples, and my marker kind of wore off here, but this is hydrogen 1. So looking at the 3 isotopes of hydrogen, and again, all atoms are isotopes. Hydrogen has 3 different isotopes. In this case, hydrogen 1, where you just have the 1 proton in the nucleus, in nuclear notation, mass number 1, well, its protons are 1. And I don't see a charge, so electrons, same as protons. And then to get neutrons, well, we just subtract our nuclear notation, and in this case, actually 0. Which, kind of weird, but it happens in this one case. Hydrogen 2, so in our nucleus we have 1 proton, 1 neutron. So we look here, we said, again, it's hydrogen. Notice it's the same. Neutrons, subtract, mass number minus atomic number. In this case it's 1. And then an electron, there's no charge written here, so it's equal to the protons. Last one, hydrogen 3. And all of these are naturally occurring. If you were to separate all of the water out of the ocean, you would definitely find some of this, you definitely find some of this, but this one's the most common, and I can tell you how to find that when we start talking about average atomic mass, which one's the most common. But back to this, see our nucleus here, see if we can do it without looking there. Protons, well, there's my atomic number. Neutrons, we said mass number minus atomic number, so in this case it's 2. And electrons, there's no charge written here, so it's the same. And then the last thing, again, this is hydrogen. To be hydrogen, you only have one proton. That never is going to change. If you get to 2, now we're talking about helium, where neutrons, those can change all the time, and you can still have the same element. Something else new then is ions. So an atom, or later on we'll talk about groups of atoms that have charges. They can be positive or negative. And these are formed when electrons are gained or lost. So another element steals an electron from you, or you give up that electron, and you do this for a number of reasons, mostly because you want to be more stable. But when you gain an electron, well, okay, so we're gaining negative charge. That means we're going to become more negative. Where here, if you lose an electron, well, okay, that's losing negative charge. That's going to make me more positive. Kind of backwards. Make sure you kind of commit these things to memory. That's kind of a sticking point, or just something easy to glance over and forget about. So if you gain electrons, more negative. If you lose that negative charge, that makes you more positive. So some ion examples here. Looking at hydrogen, okay, hydrogen, number of protons. It doesn't say, so I need to look at my periodic table. Periodic table, atomic number is 1. And in this case, hydrogen with a positive charge. Well, what's going to make this positive? This is going to be a positive. I need more positive than electrons. So 0 electrons, I lost its 1. We go to aluminum. Well, protons is never going to change for aluminum, so I go to my periodic table. Atomic number, 13. All right. Well, it says here I'm a positive 3. So I need 3 more positive charges than I do negative charges. Or you can think of as, okay, these used to be the same, but now I've lost 3, so that gives me 10 electrons. The oxygen, same process. Okay, it's oxygen. Protons are never going to change, so I will go to my periodic table. Atomic number, 8. And now I have 2 more negative charges than I should. So this number should be bigger, and it's 2 bigger. So not equal this one. I have 2 more. That gives me 2 more negative charges there. Bromine. Periodic table. I forgot my periodic table. I think it's 35. Double check me there. Bromine, -1 charge. Well, I need 1 more electron then than I do positive charge if I want to be a negative, so 36. Zinc, oh, look, we are combining the 2. So I have nuclear notation, but then I also have a charge. Well, this will really help me remember those protons because it's written right there. And then electrons. Okay, I need 2 more positive charges than I do negative charges, so that's losing 2. So if I had 30, I lost 2, I get to 28. Much, much easier if you have nuclear notation. You won't have to worry about looking at your periodic table or forgetting your periodic table like I did. And then last thing, notice on these, I have no idea how many neutrons. The reason being is it doesn't give me a mass number. You have to be given either mass number or neutrons to figure out one or the other. In this case, I have mass number, so I can figure out neutrons. So subtract 65 minus 30, 35 neutrons.